Hey everyone, this is Nick Dearbertis teaching you financial modeling. Today we're going to be solving the lab exercise or finding the cost of equity using historical prices. This is part of our lecture segment on the discounted cash flow valuation model, focusing on the cost of capital side of the model. So we covered all the material on the cost of equity, and this is the lab exercise to wrap that up and test that knowledge. So here we're using the prices Excel file from the course site, and we're going to take the risk-free rate as 2% given, and we're trying to find the beta and cost of equity for the company. Then that's the baseline result, and we're going to adjust that, thinking about, well, if there's going to be a recession, we're going to lower the market return by 3%, and what would be the cost of equity in that kind of environment. So let's go over to a Jupyter notebook to complete this exercise. So I already have the prices workbook in the same folder. So now I just need to import pandas so that I can read the Excel file into a data frame. So now I have the prices loaded, and there I have prices on the market portfolio. So this is like an S&P 500 or some kind of proxy for the market as a whole, and then the actual asset prices, the stock or whatever kind of asset that we're interested in calculating the cost for. So we have the prices, but in order to use the CAPM model, we need to convert those to returns. So I'm going to do percentage change on the data frame, and that's going to convert that into returns. And then we saw from the examples that if you have these NaN rows in there, that's going to mess up the regression. So I'm also going to do drop NA on that as well. And then I'll just assign that back into the data frame. So now that the data frame just has returns and no missing values. So now I can go ahead and run the regression. So I'm going to import stats models to help with the regression. And that's the conventional import for stats models. And then the y is going to equal the market column of that, or sorry, the asset column of the data frame. One more step before we get to the actual regression is that I need to calculate the market risk premium. So I'm going to add in here that the risk-free rate is, we say 2% from the example or problem. Yes, 2%. So the market risk premium is going to be the market returns minus the risk-free rate. And now that's in there as well. And we can assume that this is a daily risk-free rate. So I'm going to divide by 252 to get that to a daily rate. There we go. So then the y would be the asset returns, and the x would be the market risk premium column. And then the model is going to be OLS of y and x. Oh, and we need to also add a constant here. Okay, and then tell it that we have the constant has const equals true. Okay, and then the results, we're going to fit the model and see the summary of the results. So now we have it coming up here. And so out of that, we are getting a 0.8475 beta. So that's the first part, is to get the beta. And next is then to calculate the cost of equity using the CAPM model. So in order to plug into CAPM, one other piece that we're going to need is the average historical market return. So we can just take the market column and take the average of it. And this here is going to be our historical average market return. So then coming to the CAPM to calculate the cost of equity. So I'm going to set this up as a separate variable, the market return, and set it to historical, because later we're going to look at adjusting it by 3%. And then we can calculate the CAPM using that and the beta. To get the beta, we're going to pull that from the parameters of the results. So that's going to be the coefficient on the market risk premium. And now we can take the CAPM, where it is the risk-free rate plus the beta times the market return minus the risk-free. And there we are getting our cost of equity. And I can just add some nice formatting for that, 6.53%. So that's the first portion. And then it was asking, well, what if we adjust the market return downwards by 3% to take into account that a recession is now occurring? Well, we can just subtract 3% from this historical average to get the new market return, and now we have the adjusted cost of equity, 3.98%. So that's everything involved with this lab exercise of finding the cost of equity given historical prices. So thanks for listening, and see you next time.